Okay, this is problem 270. Closest binary search tree value. Given a root of a BST and a target, return the value in the BST that is closest to the target. If there's multiple answers, print the smallest. So here we got this tree. The target value is 3.174. So the difference between the target and any of those that's the smallest would be the 4. So that's why I'll put a 4 here. If you have just a single node in the tree, then it has to have the smallest difference between it and the target. So that's why you just return that node itself. The number of nodes in the tree is there's always going to be at least one node, and all the values are going to be greater than or equal to 0, but target can be negative. Okay, so so if we draw out this tree, 2, 5, 1, and 3. So the difference between, let's just say target is 3.7. So we know that 4 is greater than 3.7. So because 4 is greater than 3.7, we know, and then 5 is greater than 4, that means the difference between 5 and 3.7 is going to be bigger than 4 and 3.7. And similarly, if you had like 3.5, then because 3.5 is less than 4, it's possible that it could have a smaller difference between it and the target compared to the 4 and the target. In which case it's actually true because 3.5 is only 0.2, which is smaller than the 0.3. Whereas if you had like 4.1, that's going to be 0.4, and that's still bigger than the 0.3 difference. So you know that if root greater than target, but it's possible that target can be negative, but all these nodes have to be positive. So yeah, let's say we had negative 3.7. In that case, it's going to be 7.7, and then 5 and negative 3.7. That's going to be plus 8.7. So that's still bigger. So it doesn't matter if target is positive or negative. So we do know that if root is greater than target, then difference between any node in right subtree will be larger, implies only check left subtree. And then the same can apply if root is less than target. If root is target, root equals target, then you know it's going to have the smallest difference of 0. And then you also have, well, it doesn't say, but because it is a binary search tree, it's not all the node values have to be unique. So there's no need to check any other nodes. Like you already found the answer. So that pretty much. So this is pretty much the logic of the code in it, and then now we can just code it. Okay, so if if root.val equals target, then you just return root.val. Then otherwise you're going to check the so let's just have this return the difference, or I mean the value. Return root.val. Yeah, return root.val. And then so let's say, if root.val greater than target, so you're only going to check the left, root.left and target, and then else you're just going to check the right. So this is going to return the difference. It's going to return the smallest. It's going to return the node that has the smallest difference between it and the target, between any of the values in the subtree and the target. So we'll call this like L. Call this like R. Let's see. So you're looking at all the values here. Yeah, so you can have something like min equals absolute value of root dot val minus target. This is when, if they're not equal to each other, we still need to calculate the difference. So here, let's say this is plus 3.7. So the difference between 4 and the 3.7, that's going to be 0.3 here. And then let's say after checking the left subtree, the smallest value was like the 0.73 and the 3.7. So L is going to be 0.7. And then R is going to be 5 and the 3 points. We're not even going to check it, but let's say we do. Then that's going to be 1.3. So in this case, so if L, whoops, so L is returning the actual value to no, not the difference. Okay, so let's say the actual node is 3, because that's the one with the smallest difference out of any of the nodes in the left subtree. Okay, so now if absolute value of L minus target is less than min, then you return that. Then we're going to return the actual value L. Also, let's say here, let's say 4 to, let's say you have the tree 4, 2, 5, and then 1. Target is 3. So in this case, the difference between the 4 and the 3 is the 1, and the 2 and the 3 is the 1. So they both have the same difference, and in this case, print the smallest. So we want the 2 and not the 4. So that's why here, if L, so return L if it's less than this difference, but also if it's less than or equal, you return it, because we want the 2 instead of the 4. So that's why we have this. And then else you check the right subtree, and then same thing. If the difference between R and the target is less than or equal to min, or is less than min, then return R. And the reason why we have less than instead of less than or equal to is because let's say you had 4.5 here. Difference between 4 and the 4.5 is 0.5. Difference between the 5 and the target is 0.5. So in this case, we want the 4 instead of the 5. So we want the root and not the root dot right. Okay, so then, and then if neither of these are true, then you just return the actual minimum value. So let's see if this code works by walking through this example here. So 4 does not equal to target. Let's say, tir equals 4 target equals 3.7. So the difference between is 0.3. 4 is greater than the target, so now you're going to look at the root dot left. So now root dot left would be the 2. So now root is 2. Difference between 2 and the 3.7 is 1.7. And then 2 is not bigger than 3.7. So now we check the root dot right, which is the 3. Here, root dot right is 3. And now we put that into, we do a recursion to this function with the root dot right as the root. So now root equals 3. Difference between them is 0.7. Root dot val. Also, we only check it if the root.left actually exists. So if root.left and that. Yeah, otherwise we're not even gonna, there's no point in checking it if root.right doesn't even exist. Else if root.right and root.val less than target. Okay. So here root is 3. It doesn't have root.left or root.right, so we just finish it. Now we iterate back up to the 2. Here root.right. Oh, so we need to return, yeah, so return min. No, not min, root.val. Okay, so root.right is 3. It didn't have any children, so we returned the actual 3. So 3 minus target is 0.7. That's not less than the 0.3. So here, so 2, so it's actually 2 and so this is actually 1.7. And then here 3 minus 3.7 is 1.7. That's smaller than the 1.7. So you are going to return R. So in this case, we return the root.right, which was the 3. Okay, so now this was the root. So now we go back up to the 4. 4 minus 3.7 is 0.3. We didn't check its right. Its left was the 2. But it returned 3. So L is 3. 3 is not... 3 minus 3.7 is 0.7. That's not less than the 0.3. So we return root.val, which is the 4. So we're just going to return 4. So that should work. And it looks like it passes all test cases. So that solves this problem. So yeah, thank you for watching this video.